Hello, hello, hello. Can you
Hello.
hear me?
Yeah. Hi, can
Hi,
you hear me good?
I can hear you.
Okay, awesome. It's great to connect, Thiemo. How should I pronounce your surname? Wambsganss?
That was very good. Yeah, Thiemo Wambsganss. Yeah.
Okay, wonderful. I really look forward. In fact, a lot of people look forward to this session. As people pour in, we
Should I
are,
share my screen?
we will start in like in 2 minutes. Let the audience
Okay,
pour in,
sure.
and I'll make certain announcement about what this masterclass is all about. I'll do an official introduction about you, and we'll also set up some
Perfect.
ground rules for the audience, what they should expect, and how they can ask questions in this masterclass.
Mhm.
So I think we already have. Uh, it's already about time, and you have a lot of people already pouring in and still pouring in. It's okay. So welcome everyone. This is Saurabh Gupta, CEO Edorer, and welcome to another edition of Edorer's Masterclass. You know what Edorer Masterclass is? We basically come up with some astonishing leaders like Professor Thiemo Wambsganss and so many others from different universities and domains around the world. And these are the people who are leaders in their domains, and they discuss what they know, and they help you with your career, your questions that you may have about that particular domain, and how this can benefit you in the longer run. So today's masterclass is going to be about generative AI and how it is important for business innovation. Quickly sharing my screen, and then the platform will be all yours, Professor Wambsganss. Yeah, I am sure everybody can see my screen. Yes. So this is about generative AI for business innovation. Quickly introducing the speaker today, Professor Thiemo Wambsganss is a renowned professor for digital technology management at the Bern University. This is a very prestigious university, everyone. The Bern University of Applied Sciences in Switzerland, a great place, of course. He is a world leader in human-centered AI business systems. And so this is something so interesting. Everybody is talking about it these days. He's also the director of human-centered AI-based systems, HAIS lab at the Bern University of Applied Sciences in Switzerland. His research lies in the general area of human-computer interaction with influences from natural language processing, information systems, and education technology. He excels at how humans perceive, interact, and learn with intelligent tools. Based on these insights, he builds adaptive user interfaces that go beyond static and rule-based interaction to advance the capabilities when working and learning in the digital world. He's driven by the vast opportunities to enhance and improve pedagogical scenarios based on recent advantages in NLP and ML to enable humans to self-reliant and individually independent of an educator or their background. The crux of the matter is that he is a researcher. He's a true researcher. He really understands AI. Today, a lot of people talk about AI, and then a lot of people talk about generative AI, specifically for students, because a lot of our audience is students. For you, when somebody throws that big word generative AI on you, you do not have to sound dumb anymore, because after this masterclass, you're really going to understand, not only just understand what generative AI is, but also understand the nuances of it and how it works and how it can actually impact your own career. Now, this masterclass is going to be a 90-minute session. 60 minutes is the masterclass presentation by Dr. Wambsganss. And then after that, there's going to be a Q&A. How do you participate in the Q&A? You have Q&A in the Zoom app, and you can ask your question in the app. And after this session is done, when we'll be open to Q&A, we can pick your question from the Q&A. Also, if somebody wants to come on the spotlight and ask the question in person, you can share your audio and video if you want. You can ask that question directly to Thiemo. So welcome to this masterclass and enjoy this masterclass. Professor Wambsganss, this is all yours. We look forward to a great session from you.
Thank you very much. Let me just start sharing my screen. I think you have to give me access to share the screen, and then I can start.
Please go ahead.
A second. And I will start my presentation. Perfect. Yeah, thank you very much for the introduction and welcome everybody from my side. My name is Thiemo Wambsganss, and I'm glad today to talk about 1 hour about generative AI for business innovation. I have 3 key messages for you, which I want to present to you in the next 1 hour. First of all, generative AI is here to stay, and it will basically change our lives and also work life, whether we like it or not, right? So it's a technology which has come and which is impacting every consumers and users life, and we see already, no matter if they are old people or young people, that they interact with this kind of technologies, and this changes the way of how we can organize our business processes, of how we can design products, and how we can innovate maybe our business models. I would recommend, or I would see generative AI as a co-pilot or collaborator for augmenting human capabilities in process or workflows. This means that the human should be the pilot and use these technologies to do certain things better, cheaper, or faster in order to fulfill certain goals or solve certain problems. So the idea is really that you try to understand these tools, try to master these tools in order to augment your own capabilities better, to be a more efficient problem solver or organize certain things better. The tool and how to do this is prompt engineering, and this is one of the key master skills which we see is coming up, but which is already very important, but will be also more important in the future. So prompt engineering is basically the way of how you interact with large language models, large image models, or others in order to gain sufficient results and resources from this technology. And here I want to present you some simple rules, tips, and tools on how to interact, for example, with tools such as ChatGPT and others in order to become a good prompt engineer. And we already see that now companies are opening up job positions, job profiles with prompt engineering. But I believe that this is a skill which is as important as other skills today in order to become an efficient work leader in your certain environment or in a society. Before we start, some words to myself. So as it was introduced already, I have a professorship here for digital technology management. And basically in my research, I focus on human-centered AI-based systems. So I try to innovate systems from a human-centered perspective, where I build tools and prototypes which try to really solve human problems, human needs. For example, writing support systems such as Grammarly or others for argumentation skills, for empathy skills, and so on and so forth, or conversational agents, meaning chatbots, dialogue-based interaction, for enabling students or workers to better interact with their clients or learn in a self-sufficient way. And hence my research is very interdisciplinary, right? So my main focus in new computer action, where I really look and how to build and evaluate certain systems, but this has a lot of influence from natural language processing, where I try to take technologies, algorithms, and bring them into in certain systems to enable humans to interact better, faster, cheaper, but also in education technology or information systems, where we try to contribute to the recent knowledge gaps when it comes to the application of artificial intelligence and so on and so forth. A very important word before I start is that so I've started really from the natural language processing field, where we build a lot of our own corporas, own annotation schemes, which usually took us 1 or 2 years, right? To, I don't know, collect data, annotate data, prove the reliability of data annotation schemes, model then certain data, for example, argumentation chains or empathy, cognitive and emotional empathy. And what I've seen in the last 2 years is that with the upcoming of GPT-3 mainly, we can achieve the same results, for example, classify a text in arguments or non-arguments by using efficient prompting based on large language models. And this has really changed the whole thing of how I do my work, of how we do research, because instead of collecting data and annotating data for 1 or 2 years, we can achieve the same result when it comes to an intelligent backend in a week by using fine-tuning, few-shot learning, or others, for example, to provide students feedback or build intelligent systems. And that's why not only in my research, I built basically on this generative AI, things, but also in prompt engineering. But I'm also teaching, design a new class here in our master program, for example, in Switzerland, where we teach really this skill of prompt engineering because we believe that this is very important. And I've seen other universities, for example, University of Zurich, and so on and so on, which reach out to me to also teach this class because it's an important skill. Today, I only can present you like a short snap out of this, right? So I will start with a brief introduction to generative AI to make sure that we all have the same understanding of what we are talking about and how these things happen and how these models work. Here, I really focus only on natural language processing and large language models because we don't have the time to go into other nuances. Then we will talk about how we can use these large language models for potential for business innovation, and there the key is really prompt engineering. I want to close the session then with certain challenges and risks which I see or which we see when it comes to the use of such models and such tools, which is very important to be aware about, such as hallucination, biases, legal risks, and so on and so forth, where you as the pilot of your application or your tool or whatever, how you use this technology, should be aware about, because at the end you are responsible for this and you use this as a tool. Why should we at all think and talk about generative AI? Why is it not just another technology? I mean, we've seen that AI has different circles. We have AI winters, AI summers over the last 60, 70 years. And why is it now important for us for business innovation or for product development? Well, this can be very nicely explained when looking at the bandwagon effect, so-called the adoption rate of certain technologies. So those who don't know, the bandwagon effect is describing basically the tendency or an effect in behavioral science, in psychology, when people actually adopt a certain technology as a behavior, when it becomes normal for us that we know a certain technology. For example, when it becomes normal, hey, we watch Netflix, and everybody knows, hey, we are watching a series. When it becomes normal that we say, hey, we listen to Spotify, it means you listen to a podcast or something. Or when I say, hey, I uploaded something on Instagram, everybody knows that this is a social network. And there are two different numbers where behavioral psychologists distinguish these effects. It's first the number of 1 million users of a certain technology, because then you have certain network effects which dive in, which are an important number for technologies adopt, and then the number of 100 million users. And usually after 100 million users, we would say that this technology is something, okay, this has come to our daily life and a lot of people know it. And hence it's important to deal with that from a business perspective and, maybe think of how we can adapt to the changes and how it maybe changes also consumer behavior, which is ultimately very interesting. So when we look at this, we can see that there are different adoption rates. For example, for Netflix, it took really 10, 15 years to become a really existing technology where people watch and use in daily life, right? Facebook and the other social networks were quite faster, and TikTok broke every record when it reached 100 million users in only 2.5 years. When you look at generative AI, and here I mean mainly the technology of ChatGPT, I assume that most of you know what that is. It's basically, if you don't know what it is, then Google it right now, because you should know what that is. It's basically a program from the company OpenAI, which provides a conversation interface in a fine GA for one of their large language models. And when we look at the adoption rate of ChatGPT, we've seen that they have reached 1 million users in only 3 days and 100 million users in 2 months. And this broke every record. And this was a sign for us as scientists, as researchers, hey, this is a technology, it's impacting our lives. It's normal. People know this. Whenever my parents, which are over 60, they know what ChatGPT is. My father is using that. My cousins, which are under 20, know what ChatGPT is. They are using it, right? So it's a technology which is coming in our life, which is here to stay. And hence it's very important for us, or for everyone doing business, want to do business, to understand what this is about, how this is changing consumer behavior, how is this changing the way we work and learn. Looking at a couple of numbers, and these numbers are already outdated. because the predictions are even higher, but this is like basically ground numbers. We can see that a lot of forecasting institutions, such as Gartner, a very prominent market research institution, is really believing that this generative AI will change the way of how data is produced. For example, by the prediction that 10% 2025, so next year, of the data is expected to be produced by generative AI, and that was before the release of ChatGPT. Also, what they see is that especially marketing, when it comes to communication of products, when it comes to the interaction social media, will be largely affected by generative content. The company Gartner predicts that 30% of all the marketing communication material will be generated by generative AI, and this is changing the way of how we interact maybe with certain products. And a number which I don't really like, but which I think it's important to look at, is a number from Goldman Sachs, a big investment firm from the US, estimating that already 66% of today's occupations in the US can be somehow automated by AI, by generative AI. And why I don't like this number is basically the fact that this is often used to trigger fear of this technology, right? So I don't see this that 2/3 of the jobs in the US will be automated by AI, but I rather see this on the task level. So 66% of the repetitive, boring tasks which nobody wants to do can be potentially automated with the use of generative models. This means vice versa for us, for every one of you, on average, what are the 66% tasks in your job life which you might get help from generative models? For me, that's, for example, filling out Excel sheets, writing emails, I don't know, writing proposals for research funding, or agenda for meetings, because these are repetitive tasks where I know what I want to do, and I just have to get it on paper. And here I can really use generative AI to get help in 66% of the tasks which I'm doing on a daily basis, to then focus maybe more on creative tasks, teamwork, and others. And that's a number which I would really also use for every one of you to think about: what are the 66% of tasks you are doing every day, which you might get help from those models such as ChatGPT or other models such as Study 3 or so on and so forth. So that's how I see this number, in a positive way and not in like a risk kind of way. Well, there's a lot of media on generative AI. There's a lot of negative, positive news, and I just think it's very important that we look at this from a very, scientific way. So what is this actually about? So generative AI is a class of machine learning algorithms that can learn from content such as text, image, audio, or others to basically generate new content. So the idea is that you have certain patterns in existing data, and you try to learn from them to predict then, or to generate new data. So for text, when you take text data, for example, this is a new word, for example, which we try to generate then, or a new sentence or a new document. When we take image data, we try to generate new pixels, which then form together a new picture. When you take speech data, we try to generate new speech things, and so on and so forth. So the idea is really that you take certain data formats, you learn from them with certain algorithms, and then generate new data. And the idea for what we use this data is actually to fulfill or contribute to tasks which we have seen before, right? So in the field of natural language processing, we usually distinguish between certain tasks such as question answering, so answering questions from users, sentiment analysis, information extraction, such as finding information with Google, or when it comes to image capturing, object recognition. And the idea is that we use these algorithms to solve certain known tasks which are coming in a repetitive way in many organizations with many users, in a more efficient way, better, faster, or cheaper. And how we do this, we use models, neural networks, deep learning models. I think some of you have heard of this already, where we try to train this content on certain statistical models to identify patterns, which we then can use to generate new data and solve this task. And the trick here when it comes to generative AI is that we use a special format of networks, namely transformer networks. And that's a model basically coming from a paper from 2017, the all attention attention is all you need paper from researchers from Google, which came out with a new architecture to basically process large amounts of data in a very efficient way to map long sequences of text to other long sequences of text. And an interesting fact here is that there's always this story about the Silicon Valley and so on, disrupting the way of how innovations are done, not anymore by, I don't know, government or military, but rather from single individuals like Mark Zuckerberg or so on. But in fact, this research, as Andrew Ng wrote in one of his newsletters, was also funded by the US military, right? So the US military has funded, namely with the organization DARPA, basically research teams with millions of money to find new ways of structure large amounts of text data for processing, basically for translation tasks, right? So because they had a lot of translation tasks from different programs where they would listen to, I don't know, a lot of citizens around the world, and they wanted to translate, for example, I don't know, Arabian dialects from Arabic to English. And the way they did this is with large neural networks. And one of the networks which that it was funded for is one of the transformer networks. So it was particular a network for mapping for translation tasks, and also funded by the US government. When we look at the generative AI landscape from a business perspective, I would always recommend to look at two different layers. One time the application layer. So that's basically the application. We can use this technology to solve certain tasks or to contribute to certain fields such as marketing, sales, code, like generating code, design, voice synthesis, and so on and so forth. And that's the top layer here in my figure. At the other side, we have the model layer, right? And that's very important to understand. So you have certain foundational models from different companies, for example, OpenAI, we have from Meta, the Llama models and so on. And these models enable us to solve the applications in our business tasks. And they are usually sorted by the data type. So we have text here, which you see on the x-axis. We have usually text models, as I said, like GPT or Llama. We have code models, Codex, for example, with image models like DALL-E, speech models, video, and so on and so forth, and 3D rendering. And when you are a business person or not, you should really think, hey, what's the data type where I need help with? Typically, a lot of humans interact with text, such as emails, communication, and that's why ChatGPT is one of the applications which because everybody can use it in a very easy conversational way. But there's also other models where you can also, for example, use for speech recognition. I use Whisper a lot from OpenAI, for example, for image generation like DALL-E 3 and so on and so forth, or Codex for just improving the way of how we code. And that has like a tremendous impact, which we will see later on in the second part of this talk. In this talk, we also mostly focus here on the left side on text/code models. So in the world where I come from, maybe code is also language, right? So not necessarily natural language, but also language. And hence you can also use large language models to generate code, because it's also basically included in these models often. Another very important thing to look at before we start in how these models are trained is basically that there are two different worlds right now. Usually in software engineering, we've done a lot of work in our scientific communities to have an open source world, right? So we write papers, we publish the results, such as the attention all you need paper, and then share this with the scientific community. A way of how we do this, for example, is by writing libraries, by making code accessible for others, that they can use this to then innovate again. And this was the predominant methodology of how we shared our new innovations. However, when it comes to large language models, we've seen that closed source is gaining attention again, since OpenAI, other than the company name might suggest, was basically not releasing their models anymore for the general purpose. They say that they don't do this because they don't want to harm anyone or don't want the wrong people to get access to the models. Nevertheless, it's changed a little bit the software paradigm. And usually open source software was always very well received and was very performant. But now we've seen that closed source models such as OpenAI GPT-4 is really the leader in this race for artificial intelligence. And so when you want to use the latest model, you have to basically get an OpenAI key. You have to pay for it to get access. And that's not such a nice development than having it as an open source model, for example, Llama models or others. Right now, we have a lot of competitors in this field from all over the world, which generate new models. And I hope that the open source model is gaining traction again, because I strongly believe in the open source paradigm, because it's more transparent for governments and for businesses and so on, and hence maybe better for all of us. Well, how does this technology now work? And I think it's very important always, at least that's also what I tell to my students, to understand that for example, what is the basic task these models are trained on, and how that actually works. At least from superficial view. Why is this important? Because at the end, when we prompt this, when we use these models, we prompt the models again, and then it can help us a lot that we understand what the basic tasks the models are trained on. And for everyone who does machine learning or statistics, you know that usually these models work based on tables. This means that we have a certain table scheme here, for example, input, a text, or others, and we have a label where we want to predict on. That label can be binary, that can be a yes or no, or whatever. For example, I have an example here from Swiss company names. So basically, when we say we want to predict, is a Swiss name a company name, is a name a Swiss company name, or is a pattern of characters a Swiss company name, we can basically input here a certain text. For example, transfer me, this is a Swiss company name, so you don't know them, but probably you don't know that, but I will just go through them. Helvetia is a Swiss company name. It's an insurance company. Thiemo Wambsganss is not a Swiss company name. This is my name. It's a natural name. SPB is a Swiss company name. It's the Swiss rail network. And Peter Schmidt is not a Swiss company name. So then we make a table here where we put out the characters and we map them on a certain label. We now train a certain algorithm on that, for example, a linear regression or a decision tree or a neural network, to try to detect patterns from the left side for predicting the labels on the right side. So when you look at that, you could see that maybe one of the patterns is that if you have that you have a white space between a set of characters, this is a big identifier for that it's not a Swiss company name. And maybe the length of the number of characters is also a pattern which you can see. And then an algorithm can use this patterns to then map that to the labels. We would then learn from this training data to then predict on other unseen data, for example, a company name Mobiliar, which is also a company name. And basically, based on the patterns, maybe our algorithm then suggests, hopefully, that this is also a company name. The way of how we do this and how we deal with data is basically that we try to transform the text input data here on the left. Unfortunately, my laser pointer doesn't work here in this online setting. We transform them to embeddings, basically a pre-trained or a way of how we display or how we store large amounts of text in a vector-based data representation. And the idea is that you have multiple dimensions, like 3,000 dimensions in a vector space, and every word is basically a vector in this space, depending on its meaning and occurrence in natural language. So these are usually pre-trained based on certain facts, and you have usually a vector room where you have all the words, and then they map to each other. And usually the distance between the vectors has a meaning, how close or how similar a certain word is. For example, here dog is closer to cat than car. And this is what we call, for example, similarity or cosine distance between the vectors. What is the benefit of vectors is also that we can do usual mathematical operations, for example, to calculate the distance between vectors. And the idea is basically that the distance from Bern to another city is maybe the distance minus Switzerland plus Germany when it comes to Berlin. So I think this is important to understand that the labels here on the left side are displayed as vectors, and the arrangement of the vectors are related to each other depending on the meaning, because this impacts basically the way of how patterns are found then based on algorithms. So we take this vector representation, we take the input data in these algorithms, and then run a certain algorithm. The algorithms that we use, I've said this before, for large language models, for most generative AI algorithms are transformer networks. And here I really recommend to, for example, read the original paper, Attention is All You Need, which describes the idea of these networks. And the idea is really that you map a longer sequence. For example, I'm a student, to Ich bin ein Student or Je suis étudiant, from French to English. And it's a very efficient way of how to map longer sequence of input to longer sequence of output. So not only, for example, predicting yes or no, but also predicting more tokens. And that's what we use when we train these algorithms. Well, the question is now, what is done for the models we use here in large language models? And that can explain by a very simple task, which they are all trained on. So basically, the tasks which are trained on can be very well explained by a simple example. So I took here the Wikipedia, the first sentence of the Wikipedia article about Bern University, my employer, to explain you how that things works. So the idea is you take a unseen text of data, for example, a Wikipedia article or any book from the past. And what you do is basically a very, very simple task that you say, you try to mask the first word and take the rest of that sentence as an input. So the input here is Berner Fachhochschule, blah, 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 blah. And the word you would try to predict is the first word, die. So that's in German now, sorry for that. But that's what you try to do. And you do this not only for the first word, but for all the words in the sentence. So what you do, you have again your table where you put a text input. It's basically the sentence without the masked word, and the label is the masked word. And you go through that for all the different words. So the second word we try to predict is Berner, so Bern, the city of Bern, and you mask that, and you take die Fachhochschule ist eine Anwendung as a input. And then you do that for the third word, where you take Fachhochschule as a label, and you take the rest of the sentence as an input. And you do that for all the tasks. So, and that's what we do basically now for the Wikipedia article of Bern. And then we feed this simple task to a transformer architecture and try to adjust the weights of this regressions of the parameters, so that when a certain text comes, that the next prediction is another word, right? So it's either Berner, it's Fachhochschule, or Wurde in this case. And what the algorithm is doing now, he's adjusting the weights in the vector spaces, what he is doing, like he's dealing with vector representations, to map this words which they have seen. For example, what this sentence here is saying, the Bern University of Applied Science is a applied science university founded in 1997 in Switzerland, whatever. And what the algorithm has to do now is to have a relationship or pattern between university, Bern, and founded in 1997, because these are the words which are related to each other. And so the algorithm has to set a connection between certain knowledge which is written in the text, for example, applied science universities and 1997, in order to predict then the next word, Bern. And that's basically the task to train on. But we don't only do this for the first sentence of this Wikipedia article or the entire article, but actually all Wikipedia articles and all other books which we know and all the internet. And that's a lot of training costs, right? So I think the training cost for GB3 was like 10 million US dollars only in energy costs. But what happens here? For example, if you have a question, who is the chancellor of Germany? The next word prediction, the label would be the answer, Olaf Scholz. That's the name of or let's say, who is the president of the United States? What's the next word prediction? The answer is Joe Biden. And in order to answer, in order to predict the next word of a question, it's the answer. Or if you, for example, say, hey, you're in Singapore and you're now flying to, and then you want to predict the next word, you have, for example, and the answer would be India. The model has to make a geographic connection between India and Singapore, for example, or for other things. And by training on all this data, like historical data, Wikipedia, articles, internet, and so on, the model generates certain relations to facts, to historical knowledge, and so on and so forth, in order to do that. And what we've done is basically we've used the simple task and trained models on that in order to predict the next word. And we've done that on different data sets such as Common Ground, GitHub, Wikipedia, and so on. And we've done this for a long time, actually, since the transformer networks arrived. So earlier models here were GPT-1, GPT-2, and so on. They were not really good in predicting the next word. So if you would enter who's the president of the United States, they would maybe say Jimmy Carter or so on, but not Joe Biden, right? Because it was not representative enough in the training data. And the big moment was basically when GPT-3 came out. And that changed basically the way, because we were all very surprised in how well the model could now predict a certain answer. And that was the first time where we saw the more data we train on, the more data we train on the models, the better the result is. And with GPT-3, we saw that the model is actually able to answer historical questions, which are true. The model is actually able to answer certain questions about geography. The model is able to help us with coding, and so on and so forth. So the research community, and I think everyone else, was really stunned that, hey, by just training on this simple task of mass language tasks with the transformer architecture, we can actually generate a model which has world knowledge. And that was the big buff. And we've seen that we can ask the model to help us to, I don't know, answer certain questions, historically, whatever, and get a reliable answer. And GPT-3 was like 175 billion parameters connecting basically the patterns from sentences to next words. And since that, the models have grown tremendously and improved ever since. And that's actually what we are dealing with. So simple models, which are trained on mass language model tasks, they are fine-tuned, of course, which we come later to, based on transformer architecture. And that's interesting because it has changed the way of how we can access and get answer to information. Well, I will just check the chat before I go to the second part. Sorry. I think we'll come to the security issues and so on at the end of the lecture. So I will not answer this right now, but then at the end. So how is this actually interesting for business prompt engineering? So we've seen that we train models on this mass language model task. We have these foundational models. There's this open source, closed source paradigm. And I try usually to explain this by looking at a simple video from Microsoft. It's a big technique. I hope you can see. I don't know if you can hear that, but it's just a simple sound. There's no explanation. So what we see here is the vision, or actually the application of these models in Office 365. So by just predicting the next word, the models which Microsoft has access to from OpenAI actually is able to generate outputs such as meeting agendas, such as generating text summaries, and so on and so forth. And they basically show here how you can integrate this in your daily work tasks. For example, creating certain documents or even creating slides. Why can you create PowerPoint slides? Well, because PowerPoint is also based on code on Visual Basic, and that's why you can also generate slides. You can use it for Excel to analyze certain products, to get certain dashboards and so on. Or you can use it for efficient communication, for example, for writing emails. And that's what I use it a lot for example, to answer emails of students, because they're usually very repetitive and always the same. Another feature, for example, of these generative models is that they can summarize meetings very well, which is really cool. Otter AI, for example, for Zoom. and transcribe the meetings. You can get timelines, you can create agendas, and all this is based on training data from they are trained on, right? Because they have been trained on a lot of emails, they have been trained on a lot of agendas, and what they do is basically then map back on the vector rooms they're trained on to then generate, for example, an answer. When you look at how we can use this now for potential business use cases, we usually use the business model square, where you have three different perspectives on businesses. So first time you have the internal focus, you have the x-axis, which describes the process optimizations and the automatizations you can do in your business model. We have one time at the other side, the customer focus, which is the external stage, where you look at customer support and services. And you have a result focus where you look at what kind of new products you can, for example, innovate. And on all of this, we have a lot of potential for generative AI, as it said here, for example, for process automation, for chatbots as new products, or for customer support. Examples could be, for example, for an external stage is that you improve customer acquisition, you improve 24/7 customer support, or just customer communication. It's not easy to write well-suited emails for certain customer groups, and that's actually a skill you need to learn. But with generative models training on, for example, emails from your training data, you can enhance the customer communication for every of your employees to write better emails and to ultimately get better customer retention. A very nice use case actually for the internal focus of process optimization, for example, manual working tasks, automated routing, supply chain efficiency, or for also, especially for coding, software coding, which we'll see in a minute again. A nice focus, I think, is also that you can create new products, right? So you can personalize, for example, you can personalize your products better to your users, for example, by using traits and data in his communication to, personally create contracts or and so on and so forth. Or you can better generate leads with this by better understanding the preferences of users. Thing which we see very often in companies, actually, basically that they build new products, for example, chatbots, in order to enhance also, again, customer support. So this is just a couple of examples of what is possible, right? But the idea is really that you have certain dimensions which you can go along to think about how you can improve the way you do business. An example which I've said before is, for example, process optimization for coding. And I think that's the biggest impact which we've seen from these models. And if you don't use GitHub Copilot yet, I can really recommend it if you're into coding, because it really changes the way of how we code. With these models, you can really generate code much faster, and sections of code. You can use it a lot for software testing and for optimizing your codes and JUnit tests. And this can be very nicely seen at this simple video, which I just took from YouTube, where somebody shows basically how you enter a function and how GitHub Copilot, for example, helps you to fulfill the function. So if you, for example, enter a function to generate a number between 1 and 0, the next token you predict here, the next word, so to say, which is trained on our algorithm, is also the next piece of code. So what you can do is basically if you know what to code, you can basically use Copilot to basically generate the next function much faster. And a very cool thing is that you can start to just generate a function and see maybe what are functions from the past. But a much nicer way of how you can code today is basically you can also enter a certain comment, create a function, or a function is doing this and this, because a lot of code is commented for with the functionality a function has. And of course, the next token of a comment is then the function itself. And that has really changed, at least for myself and for the students I see, the efficiency for coding by 60-70%, because if you know what you're doing, and that's very important, you're the pilot, you take basically the input from the models, you just basically have to comment the name of something you want, and then you click tab and you see if that fits or not, or you have to adjust the comment. And that's also an application of these models. Nevertheless, most people, or what most people use is basically ChatGPT. And to just define this again, ChatGPT means generative pre-trained transformer. What that actually means, we have heard before. So generative means it predicts the next word from a language model. Pre-trained means that it's trained on a lot of data, which I've explained before. And transformer is basically the architecture of what we've seen before, right? The attention all you need paper from 2017. And ChatGPT is basically based on the GPT-3 model. And OpenAI has basically fine-tuned the model on a what they called reinforcement learning with human feedback, which I will explain in a minute. The idea was to have a conversational interface, a dialogue-based interface, to make the large language model prediction available for a huge amount of people. Why? Because natural language is the most natural way of how we interact, and hence also a very good way of how to deal or how to interact with such models. And ChatGPT has really been designed to have a human experiences and help us in certain tasks. And it answers basically the next questions which we ask ChatGPT by predicting the next word. And how that works is basically it takes a prompt, so what you enter into the field, and then predicts the next word based on the prompt you described. And that's basically the task it was trained for. So if you write a poem about artificial intelligence, it will always predict the next word and then take the whole sequence, also what it has predicted, to predict the next word again. And by understanding how that works, you can also understand of how to better efficiently prompt the model, which we will come to in a minute. So the idea is here that the conversation can be part of the prompt. So you can ask ChatGPT to create a certain prompt, create a certain poem, you get an answer, and then you ask again to improve the prompt, and you get maybe the answer you actually want, right? So, and that's what you should keep in mind. So the model is always taking the whole sequence of written text. So as I said, the basis of ChatGPT is the GPT-3 model. And I remember 2 or 3 years ago, so when GPT-3 came out, my social media feed was full of amazing things it could do. The same thing happened again for ChatGPT, just from other people, which are not tech people, because they have experience now. They had now access to GPT-3, because before mostly people did that with an API. And what OpenAI did, basically, they took the GPT-3 model and basically asked humans to write they entered a prompt, for example, a question, a task, and then received a certain answer, and then they asked humans to rate the answer. So this is a good answer, this is a bad answer, this is a not so good answer. And what they also did, they pre-scripted certain answers to frequently asked questions. For example, explain me the civil war in the United States, and they pre-scripted an answer from human experts and also fine-tuned the model in it to have basically better answer quality. And that's basically, the result is basically the model we use today, right? So they use humans to fine-tune the answers, to fine-tune the model to answer better. And they do this still today. So if you use ChatGPT and you can rate your answer with a thumbs up and thumbs down, that's again going to the model to improve it. And that's why also the models are never the same, because they get updated and they learn by the use of their audience. So, well, what's prompt engineering now? And prompt, as I said, is the task we enter here in the model. And when you ask ChatGPT what is a prompt, a good prompt is one that is general enough to be used for a variety of tasks, but specific enough to be helpful for a particular answer. And the idea is really, when you use these models, for example, ChatGPT or GPT-4 or others, or even GitHub Copilot, you know how to write the prompt in an efficient way in order to get the answer you want. And how you do this is through prompt engineering. And prompt engineering involves the design and refinement of inputs to guide a language model in producing really specific and desired outputs, the outputs you want, with the certain parameters you have. The parameters you have here are, for example, the system message, user message, and the assistance message. And so we will not dive much into this, but I will show it to you later, of how you can get better output is when you use, for example, the OpenAI playground, because you can, besides the prompt, adjust much more parameters to get the desired outcome. But first, in short, what's a basic prompt? A basic prompt is, for example, hey, 5 musicians need 60 minutes to play a piece of music. How many minutes do 10 musicians need to play the same piece of music? It's just a simple question. Or another prompt could be write me an agenda for a research meeting, and so on and so forth. And a more advanced prompt is here, what you see here, and that's what I took from my own research, is basically when you give guided instructions to the model. And I always try to say, try to talk to the model like a human, because when you explain, for example, a task to your employee, to your, I don't know, intern, you also say, please, hey, this is your task for to do. That's the goal of the task. Please don't do this, do this. And then you get a better outcome from the intern, for example. And that's ultimately, in short, also what you should do with ChatGPT. So, for example, you can ask ChatGPT to act here as a tutor, to write certain peer reviews, check the reviewed content, blah, 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 to get a certain output. And here also comes the, and we will also see later why it's good to ask to be polite to ChatGPT, to say please and thank you, and maybe use a how to say more eloquent language, because ultimately you want to come in a certain vector room in the big large language model, into the vector space where very good high efficient content is stored in, and which is then used for predicting the next word, because you want high efficient content maybe for your own task. So looking at prompting, here are a couple of examples. What you should do, try to be as clear and specific in your prompt as possible. So instead of asking the model to tell me about animals, try to describe a specific animal you want to know about, and what do you want to know about. Provide more context than you do with a person. So try to, instead of write me a poem, try to really give context of what kind of poem you want, and what's the goal of the poem, and what's the content of the poem, because with that you get a better answer of what you do. What I always do, I always write in every prompt I do, imagine you are a researcher or professor in human computer interaction in Switzerland, you work there, you write a proposal for a certain research task, because then I get ultimately into vector rooms of maybe human computer interaction and scientific writing, which I ultimately also want to produce the text. What's also very, what you should also do, try to give the model a output format, a tone and length, or aim, right? So, for example, you could say write a short introduction for an executive conference, 100 to 150 words, about the evolution of quantum computing. The goal is to have a persuasive text for all stakeholders. With this information, you get in a certain vector room where maybe persuasive text for stakeholders for executive conferences are then stored, and then with that you generate new text. And what's very important, always revise and resubmit. So experiment with the prompts and try to get it better. Here again, summarizing in a different way. The first thing you try to do, try to identify the purpose and the focus of the conversation. Try to be as specific and relevant. So act as a tutor. Imagine you are this and this. Here's an example from my part. When I generated a timeline for a research project, avoid open, overly general prompts, and revise and resubmit your prompt. As I said, a very efficient way of how to do that is not working with ChatGPT, but with the API. And a way to do this is, for example, work with the OpenAI Playground. Here's the is a graphic user interface of the OpenAI, where you can here set a system message. And that's also what they do with GPT-3. So they set a very long system message, I think 10, 15, 20 pages, where they set the role and the tone of the entire model, right? So I think there was even a leak already in Reddit, not already, like 2 years ago, about the system message of ChatGPT. You might find it, and you will see that you can set their underlying tone of the entire conversation you're acting with. And then you can enter here a prompt from a user, and here you can also enter multiple prompts to see how the model is changing. You can choose different models here, for example, set the temperature, the randomness of the answer, the length of the answer, and other parameter which might impact basically the result of your prompt. And this has really a tremendous impact of maybe when you write, for example, an application for a company or so on. You can really change really the likeness, the result and so on by using these parameters. Here's again explained of how the parameters look then in the code. So this, what we see here in the playground, is the same parameters which you can then use for an API access. For example, when you build a product based on this, where you can set the system message, the user message, the assistance, and for example, the temperature and the tokens of the model. And this is very important to understand when you also innovate with products, play with the parameters, try and revise if necessary. Before we come, let me look at the watch. So before we come to the risks and the challenges, I want to conclude this session with 3 advanced prompting techniques or an overview, which I want to give with. And I will go through them rather quickly, but I just want that you have heard them, and then maybe you can look them up later or learn then later about them. So the first one is zero-shot prompts, and that's what we've talked about now, what I've been talking about the whole time. So you give a certain prompt and you get an answer. And here the prompt, as I said, try to be as specific as possible, as clear as possible, to get a certain answer on a question, on a summary, on agenda. And that's what most people did. Here again, another format of how to use this, you can use something like act as a role to perform a certain task in a certain format, where you give a certain aim, output format, and so on and so forth. For example, act as Professor XYZ, act as a PhD students in human computer interaction to formulate research questions and give me back the results as a PDF or so on, right? And with this, you give the model specific parameters which are important to then predict the next word, to get in the right vector space of the training data, which has a sufficient quality of content. What you can also do to reduce a negative side effect of vector space representations is, and this is hallucination, so that a model is combining words which don't make any sense. This is what we call hallucinating, is hallucinating facts and so on and so forth. You can use, for example, certain words to bring the model into a vector space where this is not, where this is less likely. For example, when you want to explore the domain of law, you can say, do this according to the Harvard Law Review. Or when you generate text about medicine, you can say say according to the World Health Organization's latest report, right? And through this, you can avoid hallucinations. Nevertheless, we can never neglect this, but we will come to this very soon when it comes to the negative consonants. But it's just also a simple rule for the zero-shot prompting. The next thing what you can do is future prompting. And there, basically what we try to do is we give the model certain examples of a task they want to solve and the right answers to it in order to bring it really to the vector space, or to nudge it to go to a certain direction to learn from these examples. And there we can see that if we do this in a sufficient way, we can really get very, very positive results, similar like state-of-the-art models in the same domain. For example, I've done this for argumentation mining, for sentiment analysis, and so on and so forth. And you can say, hey, this is an argument, this is not an argument, this is a positive comment, this is not a positive comment, and so on and so forth. And then prompt a model with these future prompts, and then apply it to your customer reviews, for example, and get a very good analysis for the customer reviews in your domain and language. And that works very well. And I would always recommend, if zero-shot prompting works fine, it's okay. But if you're not very happy, try future prompting. Give the model examples of what you want to achieve, and maybe an old answer to a similar question to receive a better result. And that's how it can look like. So you give a model a task description. For example, you want to understand your customer review data, right? For example, you have a product and you get reviews on, I don't know, Amazon or whatever. And what you can do is, hey, you say you want to identify on positive and negative comments, and you give examples from positive and negative comments and their sentiments basically from old customer data. For example, the sentence is this a bad day, and this is then a negative sentiment, and you give an example of a positive sentiment, and then you ask the model to then apply the scheme to your customer data. And that works stunningly well. So we have seen a lot of research which does that, which reduces that. And instead of training your own sentiment analyzer for your customer review domain, you can basically use these models to just fine-tune them on your own prompts to get a very well result. Last but not least, a very interesting thing which we not dive here further, but which I would recommend you to look at, is chain of thought prompting. And that's basically the idea to break down a complex problem in smaller steps with detailed explanations of its reasoning process. So what you try to mimic here, to just give you an idea, is you try to mimic this system 1 and system 2 thinking by Daniel Kahneman, where you try to, let's say you have a very complex problem, and then you give the model different smaller prompts about the problem to divide and conquer the problem, also for the large language models, to then solve the initial prompts to then come to your final answer. And the idea is really, when you use this for certain structured information, for storytelling, for creation, and this requires basically a long process of steps and prompts, but it works very well for complex problems. So to summarize this again, so we have zero-shot prompts, which work very well for questions, for simple tasks. It's very quick to apply and work very well. For example, give me a meeting agenda of this and this. Few-shot prompts is with more complex problems, and when you want to optimize your work processes, pipelines, analyze customer data, rewrite email answers, then give them example of email answers you have written before or of outcome variables to get a better result for your specific context. Chain of thought prompting is what I would recommend you to dive into if you work with complex problems and to understand. There's a lot of new materials now coming out of the chain of thought prompts. There's tree of thoughts and so on and so forth. Papers coming out all the time. But this is a very interesting methodology when you work with more complex problems. To sum this up about prompt engineering, there are different principles on how to do prompting. Try to write a prompt with a high clarity and understanding. Use certain factors to divide your prompts. Try to be as specific and detailed as possible in the aim, in the output format, in the length. Try to provide context and relevant information. For example, you're a professor in XYZ, according to Harvard law, and so on and so forth, to get the best result of how you can. Also, what works very well, try to give certain conditions for accuracy, try to give examples, or also what not to do in your prompt to get a better result. Here's also, again, a summary of the instruction method. We have seen shot learning. So this is zero-shot learning. This is just any prompt. As I said, few-shot learning, provide examples of what you would like to have. Chain of thought prompting, building up on previous responses to maintain a certain context for multiple conversations. Tree-of-thought prompting, using an algorithmic tree to map out certain solutions. Solo performance prompting, and react prompting. Just that you have heard this and you might want to dive in further. So I hope we still have some time. I don't know if that's possible, but I will just do unless somebody stops me here. So in the last five to 10 minutes, I want to talk about the negative consequences. And how I usually do this, I show a video, and unfortunately, I think we have no sound here, of a Swiss novel. I don't know if you know Heidi. So Heidi, maybe I have to explain this here. Heidi is a Swiss novel about a girl which comes from the big city, living in the mountains and so on. And it's a very nice fairy tale here in Switzerland. And here, a comedian from Switzerland has used basically the novel of Heidi to prompt a video generation model. And that was the result from the model. So let's look that on now. So what you cannot hear, but what I can hear is basically the sound of Heidi. So what we've seen here is basically, as I said, a trailer for the novel Heidi. And so what we saw here is that there's something wrong with the trailer, right? So the model generates basically nice pictures of people, of a cow that is not really a cow, which we see, or of people which look like horses and so on. And the difference is that we as humans, when we see this visual information, we can pretty much see that this is not like a real cow, this is not a real human, because we have a lot of data which we see every day. We have concepts in mind, what's a human, what's not a human. Nevertheless, what we saw here is like that the model is bringing up new creatures which are not there in reality from learned data, which they are not present. And when it comes to images, we've seen other images which are not real. For example, here Joe Biden drinking a beer with the Russian president, having a third beer cup here, where we can see maybe on the first look, hey, that might be not true, and we see then that there's a wrong beer cup. Or here Donald Trump in the prison, and we see that he has very big hands or something, or other stuff where we often see that something is not true. And when it comes to image, we might see this hallucination or biases in these models because we have a lot of image data which you see everyday life, and it might be visual to us unless somebody wants to manipulate it on purpose, right? When it comes to text, the same thing happens, right? So the models generate content based on seen data, and the content can be completely crap. It can be completely made up, because basically what the models do, they generate next tokens based off seen data, and they cannot stand in connection to each other because they might sound good, but maybe they are completely factual wrong. And at the end, it's up to us humans to make sure that this is not completely wrong and validate the text, right? It's similar like the work of an intern, where you give the intern a task and then you check maybe the task again, because ultimately you're responsible for the task, not the intern. And that's the same with these models. And the difference between visual information, between image and text, is that with images we can usually see that easier than with text, because text might look good, it might sound good, there's a lot of complicated words, but it can be completely bullshit. And that's the message I want to give you at the end, right? So you're in charge of the process. Try to, if you use these models, be the expert in the domain and try to read the text and make sure that you are confirming what the model generated is true and not. And there's a lot of risk when we use these models, such as we said before, these hallucinations, where, for example, or biases, where we know the content the model is trained on is maybe 100, 150 years ago from, for example, text from important philosophers such as Hegel or Kant and so on. And for our today's moral compasses, these philosophers have been racist or biased towards male and female sex and so on and so forth. And these are information which are inherently lying in the models. We know this from a lot of research, and it's up to us to control that and be aware of that. Also, another issue is basically data privacy, which I will have you, which I'll show you the Samsung case in a minute, but also legal risks, right? So I think there's a lot of law cases still going on, where the question is, if we use certain text which might come from a legal content which is protected, is this copyrighted or not? And it's important that we are still in the driver's seat of this when we use this, and be aware that this can go wrong. 2 or 3 examples of this before we close here. So there's the case of Samsung, for example, about intellectual property rights, where Samsung workers have used basically generative AI to get a summary of confidential data, and then that data of their new patent was leaked to the servers and was basically available in the ChatGPT database. And that's important for us to know. If we use sensitive data to prompt ChatGPT, at least the free version, the data might be used for pre-training, and we might want to be we might want to be careful what kind of information we share with the model, or if we want to anonymize this, especially for business context. I think this is very important, that you don't share any risky legal intellectual property with these models, but you always have to ensure that it's kind of anonymized. Another thing which we see is that a lot of data now is generated from this model in social media or on the internet, right? And this creates to what we call data pollution of models, right? So at the end, we might have an internet where there's a lot of data created from these models, for example, social media marketing or websites, news articles. And then we take the data again to train on the data. And this generates the effect that when you train on statistical data, you make statistical predictions, your tendency to the average is rising again. And that's what we call model collapse, right? So that we get all over the results again. And we have to be careful about what's happening there when models are trained on artificial data and how this is maybe leading to then wrong predictions. Last but not least, I want to close with the quote of Noam Chomsky, a very important computer science professor from linguistics, which said basically these tools which you use there is basically high-tech plagiarism because it's generated content from others. It's learned content from others and generates new content, and we should be basically aware of this, that we might get content which is actually content of somebody else, and be careful with it. If you want to, what I can recommend you, if you're a data science developer, a business student or whatever, get into prompt engineering and try to learn what's prompt engineering, apply that, experiment with this, collaborate with other people. Here are a couple of suggestions, and to master this. Overall, I started with the key takeaways that generative AI is a technology that will change our life, whether we like it or not. I hope I could make this clear. Generative AI should be a co-pilot for us that helps us to work better in certain processes and workflows, help us to build better products, be more efficient in our work. And finally, prompt engineering is a key to master, an important skill in the future. And I hope I could give you some practical tools in how to do that and how to master that and be more efficient in that vein. And with this, I conclude, and I would look forward to your questions.
It was an excellent masterclass. There was a lot to learn, Thiemo. And I'm sure everybody really learned a lot. There are a lot of things now to practice. Of course, it also raises a lot of questions. Like, for like a general user, a student, how do they actually benefit more? This masterclass definitely poses a lot of things at you. You have to be fearless with generative AI. I think the first thing is that generative AI, I mean, like, you don't have to do a lot of things. It is already coming to you. Like, for instance, Thiemo said, it is already coming in your Gmail. It's already coming in your other, softwares that you use. For instance, if somebody is using Canva, it'll automatically suggest that, okay, hey, I can suggest and I can come up with some images or text for the entire presentation. If you're writing articles on Medium, even Medium starts suggesting generative AI, so you can come up with those kinds of things. So the thing is, you should be open to accept that, because this is definitely going to stay. This is future. Things are going to be better and better. So as a student or as a researcher or as a professor, you understand there are multiple ways in which you can actually use these tools in your classrooms. Now, before I open the session for Q&A, and for this Q&A, this is going to be the next 30 minutes. Please raise your questions. If you have questions, you can ask in the Q&A tab. Otherwise, you can just raise your hand and I'll just pull you up and put you on the spotlight and you can ask your question. Before that, I have a question, Thiemo. Now, we understand that with generative AI, students can really use generative AI, and there's so many things. In fact, you ended with this, that generative AI is nothing but high-tech plagiarism. So you understand there is a lot of frenzy with students when they're going to use it. Even faculty members, teachers, when they see that students, if they're going to use this generative AI, like for instance, I'm going to give you an example. Let's say in a class, students are asked to come up with a presentation on a particular topic. 10 out of 20 students use a generative AI tool to create that presentation. Now, and when they come and present, and maybe it comes up, of course, the prompt is going to give different outputs, but maybe the prompt is also pretty much similar and the content is also pretty much similar. So don't you think that it's going to kill some sort of creativity? It's going to be repetitive. And if this should not happen, then how should students who are in the same class, or let's say with a lot of peers, how can they actually use it to come up with unique content? Is it going to be more inspirational? How do you actually put this up?
Yeah, good question. I think there's a lot of dimensions to this question, right? So I think from the student perspective, you can use these tools, right, to better brainstorm, for example, give lists of something, maybe to discover the unknown unknowns of how we say, right? To discover themes out of the things you've thought about, right? And maybe create this. At the end, I think it's very important to use this, as I said, as a co-pilot, as a collaborator for yourself, right? So it should augment you in your task, which you're doing, and nothing more and nothing less, right? And especially when it comes to education, I think this changes the way of how we maybe teach things and how we basically have to also confirm certain knowledge gaps, right? So we as lecturers, professors, whatever, we have to not only maybe change the content we teach, but also the way of how we examine the content, right? So when it comes to colloquial exams, presentations, so on, there should be more emphasis on this, and then testing also the students if they have really understood something. To my students, I always say, if I get a report or if I get a presentation, I assume that if I see some text which are high level and sounds very general, I assume that you've generated ChatGPT, right? So it's your task to show me that you've done more than this by generating better output, generating nice figures, generating things what other groups have not done, and the bar raises with this, right? So if everybody uses ChatGPT, I hope then that the content is getting better. But what we see is actually often that the digital divide is getting larger, right? So students who use this in a very good fashion are becoming better. Students who don't use this because they don't know about the principles of prompt engineering, they get worse because the average bar is getting higher, right? So I think it's up to students to get familiar with this, to learn prompt engineering, to get into the upper bound of the digital divide, and to get not lost to others.
Okay, I think that's a nice take. So guys, this, you have to understand that you need to understand what prompt engineering is. In fact, we have done so many masterclasses. I'm sure you would be already trying your hands on at prompt engineering. In fact, we'll be coming up with a masterclass on prompt engineering. But just thinking about another question here, you also showed that the data that is presented and all the models that are being trained currently, it has just 1% AI created data and 99% data which is available on the internet or otherwise. So if more and more content creators are going to create content using generative AI, and you say that this percentage is going to go up from 1% to 10% to 20% probably in the next couple of years. So don't you think that things like hallucination on the data, fictional data, or same repetition is going to happen? I mean, like, what changes would, or let's say, what changes are these current models adopting so that this kind of bias can be overtaken?
It's a question to me, right?
Yeah.
Yeah, it's a little bit difficult, right? So I think the bias is in the data, right? And we're trying to work with this and trying to get around this with human feedback and so on. But as humans, we're naturally biased, right? So the texts we've seen from the past are this way. But the good news, this is the bad news, but the good news is in my own research, I've done a couple of experiments, and it was published, for example, at last year's Email NLP conference, which is one of the leading conferences there, or the leading conference there. And we've seen that the bias is in the models. They are sometimes, not gender conform, or how you want to call this, but it doesn't transfer to student writings, for example. So if you get feedback and so on. So we see no evidence in a lot of experiments. We see that humans get more biased in their writings, for example, when it comes to gender bias. But we see it in the models, right? So this is a very good news that humans are aware of that. And at the end, it's for me, again, educating the user to be aware of this, and so to counteract the bias from a human reader interaction perspective. From a technical perspective, there's a lot of things what we're trying to do to counteract the bias, but at the end, the question is a little bit difficult, because who decides what is biased or not, right? This is a lot of philosophical question. And this is changing over time, right? So we have different moral standards 50 years ago than we have today, and maybe we have different ones in 50 years. So I think at the end, it's again educating the human to be responsible, to use this as your own content and to make sure that you are aligned with this.
Okay, so keeping in mind that we have limited time, I'm going to pull up a few people. Om, you are allowed to talk. Please go ahead and ask your question. And I'm putting Abhishek in the spotlight as well. Om or Abhishek, whosoever is available, go ahead, ask your question. Okay, I think maybe they might have an issue with, okay. I think we will take up the questions from the Q&A meanwhile. So Dr. G. Suresh Kumar has a question, okay. What are the best free AI tools that are available?
The question is, again, what do you mean with AI, right? So if it's like natural language processing tools, so I think, from my perspective, I still use a lot of ChatGPT, right? I think that's commonly available for everyone. And yeah, I use this, I have the Pro account, but I think also the normal account is good to use. And they're coming up tools, I think, probably every week, every day, right? So I think yesterday my student showed me something, Perplexity AI and something, but I don't want to give like how to say certain recommendations for any of the tools, because I think they're all good in some part. So going with ChatGPT and then finding out other tools is maybe the best thing you can do. And then, as I said, educating yourself in the use of the use of this technology, no matter which tool you use, I think is the better way to go.
Okay. Can you elaborate? There's a question from Jeet Banerjee. Can you elaborate better input, better output for generative AI?
I'm not sure if I understand what the participant means exactly. So input, output. I mean, I think that's what I try to cover with
talking
prompt
about
engineering.
how specific you can be in your prompts. I think probably
exactly. So I think that this is what I try to cover in this rules for prompt engineering, right? So the better you give input, if you want to call it, to the model, right, to the tool. And that's, I'm not talking about the foundation model, but when you use the model, right? Because the input could be also the data you're training on. But this is, I think, another thing then. The more specific they are, the more context you give, the more routing you give, the more elements you use when you talk maybe with your colleague, the better it is, right? And if you're polite to the model, if you use adequate words, if you don't make any typos or spelling mistakes, you're more likely to get into vector spaces where professional text is based and stored, and that's actually what you also want to generate, right? So by providing better input, you also receive better output. By providing more precise input, you get more precise output. That's like a rule of thumb.
Okay, of course. How do we choose the right limit? Okay, I think before that, there's another question. Okay, so Jeet, if you want to connect with Thiemo, you can actually reach out to him on LinkedIn. And if he finds you interesting enough, he will connect and you can then discuss any sort of collaboration with him later. Okay, for the hands-on practice session on generative AI, we will be coming up with a prompts engineering masterclass. Probably in that class, we can have more of hands-on practice and examples with that. How do we choose the right LLMN for generative AI needs? Okay, is there a typo? How do we choose the right? Thiemo, can you see the Q&A?
I think so, yeah.
Can you click on that? There's a second last question.
How do we choose the right LLM for our general AI needs? You mean this one?
Yep.
You mean we choose the right large language model?
Yes, I think talking about large language model, yeah.
Genau, yes. So I think, yeah, that depends again which tool you use. So I would recommend, and maybe that's the question, the other one, to use the OpenAI Playground, because you have access to a lot of different models. and you can try them and different parameters, right? So, and I'm a friend to always work with the core models, right? So there you can use GPT-4 Turbo, and that's what I use a lot, right? So the Turbo model is like the cheapest one when it comes to power and efficiency and so on, and you get very good output. So GPT-4 Turbo is very well. Of course, there are a lot of other models from Google, from Mistral, from Claude, or whatever. So I have not tried them all, but I think they might be also capable for certain things. What I use, it depends on your needs, and then you might want to adapt this whenever new models come out. What I use is basically GPT-4 Turbo or GPT-4.
Okay, cool.
But then it depends what your needs are, right?
Yeah. Probably we'll take the last question. This is a little offbeat. Sumit Singhania asks, how important, because we are an international boot camps platform and we keep doing a lot of boot camps internationally, and we take students abroad for 6 to 7 or 8 days, where they learn different skills like business analytics or data science and whatnot. How important are, like, I think somebody's asking you as an academician, as somebody who's traveled the world, how important are international boot camps or going abroad on short study trips? What are your thoughts? Some student is asking this.
Yeah, I think it's always good to invest in yourself, basically, right? So what I took always as a rule for myself, I think there's like this number that you say a company should invest 20 or 15% of their revenue in own, how to say, own development, how to say, in innovation, right? And that can apply to yourself too, right? So if you invest 10-15% of your income in yourself in development, and a boot camp and a international conference and international setup is exactly that, right? So you're investing in yourself to become innovative and develop yourself. And I think this is always good. And education is something, or this experience is something which nobody can take from you, right? And it's a benefit, no matter if there's a war happening or I don't know what, a international crisis coming. The experience you have made, the certificates you've gotten, whatever, stays, right? And that's a big benefit, and that's why I think I learn a lot through the scientific conferences I attend. I did this already as a student, when I basically took always part in student group conferences and so on and so forth. And I would definitely always recommend this because it's like a capsuled experience which brings you forward and which takes you out of your local environment and puts you into a new context. And that's always good, going out of your comfort zone and trying something new.
Do you want to
I don't know if
describe?
this answered this, but it was very general.
No, this definitely answers. In fact, I would have a question like, imagine your college days. Do you remember any college trip which you went, which was an international trip, which really had a great impact on you as a young student back then? Even if it was in
So yeah.
Europe, in some other country?
Yeah, I mean, I was very lucky that I did a lot of trips. So I did an exchange with the US. I did a half year in the college in Canada. I did my time at Carnegie Mellon University. I did the time at Cambridge in the UK and so on. And I even did a semester abroad in China and Beijing. And all of these experiences actually were very interesting for me because not only you get to know new people in different contexts and so on, you also learn about other cultures and blah 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 blah, and you see something it's nice to travel to. But you also, you're also in a new environment where you're eager to learn. You also learn then more, how to say, skills which bring you forward in your career development, right? Because you maybe you open to new things. So in my daily work today, maybe I think, hey, yeah, okay, if my usual boss tells me something, I might not take it for granted so much because I know him very long. If I go to a new workplace, I'm naturally more open, and that helped me a lot, right? So through all the trips and through all the stuff I did, I always learned a lot, and I would never miss them at all. Also, it's hard at the beginning, to be honest, to go. I think, also I went always for a longer time, like a half year, so on, and then sometimes you miss your home and blah blah blah, and your parents and your family. But it's always, when you look back, a very very good experience.
Okay, awesome. There's one last question. We understand how important is business analytics and data science, and it is in today's world. How do you think AI can help data science students or business analytics students, how it can impact them? Are you aware of some ways?
Yeah, I think I think that's what also from a general perspective, I think AI can, of course, help you to learn better and work better, right? And I think examples are that you can get feedback in the way you learn, right? For example, if you do, I don't know, learn about algorithms, learn about tools, you can use ChatGPT to get feedback on that. That's, I think, what a lot of students are doing already. Read about this teenager who has done like a math study program on his own with ChatGPT, right? And at the other side, it helps you to become more efficient, right? And at the end, there's a lot of people who maybe know data science or whatever, but they don't get the job done, right? At the end, you can be proficient by getting jobs done, and that's how you shine, right? And getting good results. And this is what these tools can ultimately do, right? So you can do maybe data analysis better, you can better code. I think there was also the question how it impacts coding, and that's what I tried to do with the short video on how the Codex model, on how GitHub Copilot can help you do better code in a better quality, in a faster way. And I had last week a talk with somebody from Microsoft. I think they did an internal study and on Git pushes basically, and they saw that it raised the bar by 15% or something by using the GitHub Copilot model. And there was another, so there's a German company called Bosch, I think, and she was also there, and she said they're rather looking at 50 to 60% efficiency when it comes to coding, right? So it's definitely something you want to look in when you do data analysis with Python or with other tools.
Okay, absolutely. It really makes a lot of sense. I think, that was really awesome. And I think we reached the end of today's masterclass. And before I wind up the day, there is a little announcement. So we have this next masterclass coming up by none other than Professor Jochen Wirtz. He is one of the world leader when it comes to automation for customer service and service strategy. He is also the vice dean and market and professor of marketing at NUS Business School, National University of Singapore. So please feel free to come on the website and you can register for this. Of course, it's a free masterclass and there is a lot to learn. So thank you so much, Thiemo. I think I'll just end the poll here. Thank you so much. There was a lot to learn and we really look forward to whatever that you've taught to actually using it in our day-to-day. And thank you so much for enlightening us. Have a good day.
Thank you very much. Have a good time. Bye-bye.
Bye-bye. Take care.